Alright, we're starting in the directory we were in last time, and this time we are going to be adding in resources. And a resource is something like a texture, an audio clip, or a font. So let's get started by creating a new folder and call this resource. Then we're going to add in a new file, call this resource.hpp, and we're going to want one for texture as we'll be reading in textures differently. So texture.hpp. Now what we're going to want to do before we start writing these is to fix up some of the code that we had before. In state, we're going to want to add a protected scope, so protected, and then we will say data star data, and every state child is going to want to hold data, and that's why we're putting it in here. As we haven't included the game engine, it shouldn't know what data is, so I'm not understanding why this isn't throwing errors. But we're going to want to be able to tell it data is a part of game engine and it is a struct. So we'll say here struct data, and that should allow this header file to know that data is part of the namespace GE, and so when it is included, it will be able to find data. Now we will also want a constructor that takes in data. So we will say state open paren, then data star data, we want it as a pointer, and then colon data open paren data, and then have curly braces at the end. Now we will go into handler. In add state, we will want to check to see if we want to remove the state beforehand. Let's say we're going from menu to the game. We don't want to keep that menu around, so we'll have a boolean called removing. And we're going to set that by default to true, because most of the time we will want to remove the previous state. And if we are removing, so we can put this here, if removing, then we can just call remove state. And this will remove the top state, and if that top state is empty, it will just do nothing. And now we've got all the fixes to our previous program, so let's close out of these and let's get started on loading in resources. Now I've added this readme into resource to show how we will be reading in all of our resources, whether that be a texture, font, or audio. Now in the main configuration path, we will be pathing to a texture config, or a font config, or an audio config, and config is just an arbitrary name. I named it config as in configuration, just because that is easy for me to remember. You can name it whatever you want. And I have also created a ssconfig for spritesheets. So spritesheets we will handle differently than regular loading in resources, as we will want to be able to grab separate images from a single image. So this is the gist of how we read in resources. Let's get to actually building the resource. To get started, hash if and def resource HPP, and then let's define it, hash define resource HPP. Now we can call namespace GE, and because we're going to want to be able to load in multiple values into one key in what we will be using as a map, so let's include that up here. And let's also include string. We're going to need to create our own data structure. So this we're going to name the class resource obj array, so R. And this is going to be a template class, so let's end that with a semicolon, and it's going to be a template as we don't know what type of resource it's going to be. So template class resource obj. Now we can create a public scope, and we can also create a private scope. In our private scope, we're going to have a resource object, and this is going to be a pointer, and we can call this objects. All right, and we will also want to know what the size of this array or pointer is. Unsigned, as it can only be positive, int size. Now we can create a constructor for this, so resource object array, and have this take in resource object pointer objects, and then also an unsigned int size. Put a colon and then say objs inside parentheses, obj, and then also size, parentheses, size. And then end that with some curly braces. On our destructor, we can just say tilde resource obj array, and then we can say size equals 0, and we can delete our objects. And because it is an array that we declare as a pointer, we can just use brackets and end that with a semicolon. Now we're going to override the bracket operator. So we will say resource obj, as that's what we're passing back, and operator. So we're overriding an operator, and then the operator we're overriding are these brackets. And in the parentheses, it needs to take an integer, and we can call this index. Now we can pass back return objects at our index, and that with a semicolon. And we will also want to be able to get the size, so we can say unsigned int get size and just return size. All right, now we've got how we will store our objects. Let's now create our resource class. So this will also be a template class, and it's also going to be resource object. Every time we declare a class that is a template, we have to restate our template up above it. So here's our new class, resource. And let's create a public and a private scope. In our private scope is where we will want our map. So we can say standard map, standard string. So this is our key, this first part. So the name or whatever the name of the multiple images are, comma, and then our resource object array, taking our resource object, so whatever this resource object is, it's passing that through the template here, and then we're going to have this resource object array as a pointer. And so we can close that, and now we can say our resources. All right, now what we will want to do is to load in our resources from a file. So we can say void load standard string and have this be path, open and close curly braces. As we are reading this in a file from a path, we will want to have fstream, our file stream. So let's include that up above, hash include fstream. All right, so we have the path, so we can create a new standard file buffer, and we can just call this FB for file buffer. And then we can check to see if we can open it. So if f not fb.open, and this is going to be our path, and this is going to be standard iOS in as we're reading in the path. So if it cannot open this path into our file buffer, then it will throw an error. So to make this error easy for us to read, we will have to include hash include iostream. So we will print out this error to our console. Standard cout error could not open path, and then one tick, two arrows, our path, and then another tick, and standard endline. All right, now this will throw an error if it can't open up this path, and we'll be able to see where it fails. And we will also want to stop the program from running. So here we can say standard exit with the value of -1, something failed, and that failure was that it could not open the path. All right, now after we've run through everything, we will want to close it. So let's do that now, fb.close. So let's create a input stream, so standard iStream. And we can call this is, and it will be the input string of our file buffer. So we can say and fb, so point to where the file buffer is. And then we can say while we have an input stream, then we can create a new variable, standard string, and call this temp. Then we can do standard get line. This will be our input stream as well as our new variable. So every time there's a \n, it will take up until that \n from our file buffer, and it will store that in temp. and then input stream will go to the next line and try and continually get those in from our file buffer. And as you can see in the README, every single line aside from our sprite sheet has a colon on it. So our texture will be different. That's why we created a different .hpp. But everything else will have a colon on it. So for regular resources, we can say if temp.find, and then single quotes, as this is a character, and we're going to put the character for a colon in, equals standard string npos. So if it cannot find this colon inside of our string, then we're just going to continue, as we can't read anything in because we don't know the path on the right hand side nor the name on the left hand side of our colon. Now we're going to create some variables for ease of understanding. We're going to have standard string root, standard string first, and standard string second. And now to have our configuration file simpler, as we don't want super long paths to where our textures are or to where each config file is, we're going to be basing it on where our current configuration file is. And we can just strip everything up to the last slash and append that to whatever the next value is. So root equals our current path dot substring, and we're going to go from 0 all the way up to path dot find last of, and we're going to single quotes, as this is a character, we're going to find the last slash, and we're going to do +1 to include that slash in this string. Now in first, we are going to want this to be our current line, so temp dot substring. This is going to be 0 all the way up to our colon, but not including the colon. So temp dot find single quotes our colon, and that's it. And then second is going to be slightly more complex. We're going to go from temp dot substring, and we're going to do temp dot find our colon, and we're going to do +2. As to keep this readable, we're going to want a space in between our path, the colon, and what our key is. And then we're going to have that go all the way up to temp.size -1. Now that we have our path and our name, we're going to want to load this in for real. So let's create another function that we can call to load our resource, so whatever this resource object is, into our map. So void load, we're going to have standard string name first, and then standard string path. Now we're going to create a new resource obj, and this is going to be a pointer. We can call this object. This equals a new resource object. Now we're going to check to see if not our object can load from file, and this is our path. Then we will delete the object so there's no memory leak. We will print out standard cout error could not load resource single tick our name single tick comma from path single tick our path and that tick and standard and line. And now if we can't load it in, it'll print out could not read whatever our name is from whatever our path is. And now let's quit it. So standard exit with the error -1, and we can end that with a semicolon. Now all we have to do to load it in is say resources at our name, whatever our name is, equals a new resource object array of type of our resource object, and that is our object right here, and also it is of size 1. We can end that with a semicolon. All right, now we've got loading in of a single resource. What we need to do is to be able to retrieve that single resource. So we can say resource object array of our resource object, and we can say get resource standard string name, open curly brace, return resources at name. And we will also want to dereference, as this is a pointer and we're getting the exact object. And then we can end that with a semicolon. All right, and we can hit enter. And now that we have this load in function, we can call it inside our input stream. So down here we can say load first, so our name, and root plus second. And one thing to real quick just make sure to fix is if it cannot find a path, we're going to want to just have root be an empty string. So let's put this as a ternary operator. Path dot find single quotes, as this is a character, slash, if that equals npos or standard string npos, and then it can't find it, so this first value is an empty string. Otherwise, it is our path all the way up to that last slash. Now we have the entire resource class written out. As there's some semi-complex code here, if you have any questions, please leave them in the comments below. Let's now test this out. So we can go back to our main. Temp is now erroring because it's a child of state, and if you remember, in our state, we now need to pass data in. So let's go back to main. And let's create a new constructor for temp, and this will hold GE data, star data, and it will then pass this value, GE state, to our state constructor, as it is a child of state. And now if we pass data in here, let's say data, it should hopefully not give us any errors. Now let's include resource in our game engine, so that way we can access it in our main.cpp. So up here, hash include resource slash resource.hpp. In our main file, we can now create a new variable. Let's call this GE resource, and this will be of type SF texture. And we can call this texture. Now we can create a temporary file here, call this something like temp texture.config. And in main, we can now say texture.load, and this will just be temp texture.config. And we will be pathing it based on wherever our executable is. So because our executable is in this main file and it's with temp textures, we don't need anything in front of it. We can end that with a semicolon. Now I've included an image I have taken myself, so that way I won't get copyright stricken, and we will try and load this in. So in temp texture, we can say yt.img colon, and then the path to it is nothing, so we can just say image.jpg. And now in main, we should actually move these into our state class. So let's do that real quick. Control X, and we can put this into the constructor. So it's loading in. We can now create a private scope to host a temporary sprite. So SF sprite, and we can call this temp. Now to get the image, all we have to say is temp.set texture to texture.getResource, and this will be what we call it in our temp config file. So yt image, I'll just copy this over, and it is the 0th index. We can end that with a semicolon. Now in render, we can say data arrow window dot draw, and this will be our temp sprite. So we can save that. And now if we compile it, we can see that it compiles, and then main.exe. we have the image, and because it's a super high resolution image I took on a DSLR, you can see that it fills up more than just the screen, but that's not what we're testing for. We can see that the image loaded in, and that's really all we care about, so let's quit this. One trick I learned, if you see a little spinny guy, you can press Alt-Tab, and then click on it, and then Alt-F4, and generally that works. Sometimes you just need to spam Alt-F4 to close it, and hopefully not close out your IDE. Alright, now we know that that works for loading in resources. That can load in audio and fonts now. We've demonstrated it with a texture.